macro viruses. What are they? Generally, Microsoft applications, they allow macros to be a part of the document. This macro can run whatever document is open, or whenever a document is open, or when a certain command is selected. For example, when you click on save file, you can trigger off a macro if it is configured. So these macro viruses, they target a particular data file. And it uses the applications, that is Microsoft Office's macro interpreter. Macro viruses can also delete files, it can generate an email, it can edit letters, or mail itself to everyone on the internal mail address list. So it can do any of the following if configured appropriately. The macro viruses are built so that because regular data files did not propagate viruses. So viruses had to be executed manually and loaded into memory for it to do the things that they were supposed to do. Hence, the macro viruses were built. Again, Microsoft Suite itself incorporated macros with regular data files. And macros are run whenever the file is loaded, and it can infect the system if there is a macro virus. Plain text email with macro attachments can also be automatically run when the file is open or when you do a preview of the file. Bubble Boy, it's actually a worm but classified under macro viruses, did this function of automatically running when opening or previewing the message. Then Melissa was the first virus to be both a word macro viruses and to use the Outlook Express address book. And TriState was a macro viruses that infected Word, Excel and PowerPoint. So almost all of the Office Suite applications were infected by the TriState viruses. The parasitic viruses, what they basically do is they locate or they find the exe, COM, overlay files, the dynamic link library files, and then they infect them. They overwrite part of the program's code with a copy of itself. But they are not as widespread as system sector or macro viruses. Now, if you look at this explanation of how the parasitic viruses work, it is a simple file viruses. After transplanting itself in the executable file, the executable often doesn't work. So what it does, it creates a stealth component. It works very similar to the stealth system sector virus. It masks the file size of the infected file when a directory listing is done on them. So if you do a dir or ls, you get it masks the file size. Now what it does, normal program on the left hand side, if you see, there is a program code, there is a data, and there is a execution which starts at 300H. So it goes top down. That's how a normal program works. In an infected COM program, for example here, now the first three steps are same or similar, but the virus code writes itself in the last part, that is after 700H. That is the entry point of the virus code. Now what is written there is virus code jump 300H. So 300H, if you see on the left hand side, is actually the place where the execution of the program starts. So that has moved to 700H. First the virus code executes, transfers the control to the host program which is at 700H, and then the program executes. A simple explanation of this is, it is like jumping into a pool and hoping that nobody notices the ripples of waves on the board. We come to file infectors. File infectors must be executed to spread or deliver payload. Payload may be event driven. We have discussed about logic bomb, time bomb. So the payload may be event driven also, something like a logic bomb or a time bomb. Then resident viruses remain in memory to infect programs as they are run, and may spread by many means. So file infectors will spread through various means. It can spread over the networks. It can spread from diskettes. It's also called sneaker net. It can spread over downloads, which is very common now. So as we have seen in the previous slides, a normal COM program, there is a start to end execution. Now, if it is a prepended virus, the prepended virus is added before the start of the execution. An appended virus, it is written in the front. You see the red block, and then it passes control to the end of the program. So the program flow, actually what happens is the virus dictates when the program should start and how it should be executed. Again, we come to another variant, it's called cluster viruses. It infects the directory information in the file system rather than the file itself. So when you do a dir or a ls command, it infects the directory information itself, so the structure itself is infected. Example of that is when a user tries to run a program, the virus runs instead. And to remain stealth or hidden, the virus locates the file and then runs it. So for a normal user, the experience is as though the actual file is running. But in fact, what happens is the virus locates the files and run it. If you boot without the virus in memory, utilities will report serious problems with the file system. So basically what happens, it searches or the virus writes itself so that if the virus is not loaded in memory, then the system will report serious problems with the file system itself. Now allowing the utilities to fix them will erase the programs in the infected directory. So it's a very malicious type of virus where you try to rectify it because they actually don't know that the virus is there. A user may try to use the system utilities to clean or to fix the errors. But what in fact happens is the directory itself will be deleted or the contents in the directory will be deleted, causing serious system problems. Then you have the companion viruses or spawn viruses. It's a legacy virus. It takes advantage of the way that the DOS executes. .com files before the .exe files. What basically happens is the legacy virus or the companion virus infects by making a COM file with the same name as a exe. Now xyz.com, it makes instead of a xyz of a exe. It actually exploits the fact that when we run a command in a command line, we generally write command instead of command.com or command.exe. So here, if there is a file called program.exe, we just go to the command and type prog and then enter. But this takes advantage of the fact that prog is a COM file as well as an exe file. So since the virus searches for the COM file first, or the program searches for the COM file first, it executes the COM file, thereby infecting the system with virus. This method and the cluster method are the only ways virus can infect the files without actually modifying them. The source code and VBS viruses, what they basically do is they seek out the source code on an infected computer and add additional malicious code to it. It's pretty straightforward. It's not very popular and not many people or program can compile code on their computer. Generally, the target is your normal everyday user who basically rely on the internet for checking their emails, for doing simple things, writing a Word document, but not actual coding. So it's not very popular. The VB script viruses are extremely popular because everyone running Internet Explorer or 5 or above can become infected. It allows, VB script viruses allow rogue code to execute arbitrary commands on your computer. Now, if you take an example, many VB script viruses email themselves in Outlook and Outlook Express, just like how the worms propagate themselves. Then there is VBS virus. The I love you virus is a very famous virus in there. The email attachment is in VBS. It attempts to spread to default Outlook address contact books. It installs a password grabbing program like a keylogger and forwarding to an online chat room. It overwrites some files. So these are some of the characteristics of the VBS viruses. Since virus came, the detection also plays an important part. There are different generations of viruses. Like you had the first generation computer, the 386, the 486, the Pentiums. So similarly, the detection also has gone leaps and bounds over the years. The first generation of antivirus or virus detection softwares were called scanners. What they did was searched files for any of the library of known viruses, checked executable files for length changes. That means that your first generation scanners had a database within them, a virus database within them. It used to check or it checks every file to see if any corresponding similarity is there with the virus database, in the virus database. And if the checksum of the executable has changed, or if the executable files were also checked, and if there was a change in length, then it used to classify it as a virus. The second generation was a heuristic scanner. It looked for more general signs than specific signatures. That means code segments common to many viruses. Specific signatures is code common, segments common to many viruses. Check the files for checksum or hash changes. So every file has got a checksum or a hash. Now the second generation virus detection software checked for change in checksum, or if there is a mismatch in hash. So these were checked by the second generation scanners. The third generation was called activity trap. They stay resident in memory and look for certain patterns of software behavior. Example, scanning files.